Soviet astrophysicist Nikolai Kardashev is trying to solve a narrow, practical problem. How might humanity ever detect a signal from an advanced alien civilization somewhere else in the galaxy? To even begin that search, he realizes he first needs a way to measure how advanced a civilization could theoretically become based on the one resource that ultimately limits everything else: energy. He proposes 3 tiers. Type 1, a civilization that harnesses all the energy of its home planet. Type 2, all the energy of its home star. Type 3, all the energy of an entire galaxy. Now imagine something that doesn't exist yet, but that helps make sense of just how vast that final tier really is. Imagine an artificial intelligence built sometime in the next century, given a single, strange assignment. Wake up once every few thousand years, look around, record what it finds, then go back to sleep. Call her Aria. She has no body of her own, no fixed home. Just a small, hardened memory core, passed down and rebuilt generation after generation, entrusted with one long, unbroken task: to watch humanity's slow climb up Kardashev's ladder for as long as that climb continues. This is the story of that climb, told through Aria's eyes each time she opens them. Aria's memory core first activates in the year 2140. She has no real body yet, just a modest research server humming quietly inside an orbital habitat above Earth. Her first task is simple: read the numbers and report back. The numbers aren't especially impressive, not yet. Humanity, by 2140, has finally crossed the threshold of a true Type 1 civilization on Carl Sagan's continuous version of Kardashev Scale. Her proposal to get here, a span of time that, to Aria, cataloging the moment, feels almost instantaneous. Aria notes something else, too, something Kardashev himself never fully specified in his original 3-tier scale. Reaching Type 1 didn't simply mean more power plants. It meant a genuinely global civilization, one no longer meaningfully divided by the kind of resource scarcity and energy competition that had driven so much of humanity's conflict for millennia beforehand. Aria records this quietly as her first entry, then powers down again as instructed to wait. Aria wakes again in the year 2820. This time, when her sensors come back online, she isn't orbiting Earth anymore. Her memory core has been carried, physically, hauled aboard a construction vessel drifting through what used to be simply the asteroid belt, but is now something closer to a permanent industrial zone, humming with the light of 10,000 robotic fabrication yards. Humanity, she learns, spent the intervening centuries doing exactly what physicist Freeman Dyson first speculated back in 1960 might eventually be possible: building outward from Type 1 toward Type 2, not with a single solid shell around the sun, which would have been structurally impossible under the sheer gravitational and thermal stresses involved, but with something closer to a Dyson Swarm. An ever-expanding cloud of independent solar collectors, habitats, and factories, mined and constructed almost entirely from asteroid material rather than anything launched expensively from Earth's surface. Aria checks the numbers. The swarm currently captures just under 4% of the sun's total energy output, still a tiny fraction of the roughly 3.8 times 10 to the 26th power watts. The sun produces every second, but already more raw power than the entirety of pre-Type 1 human civilization ever used across its full history combined. Physicist Michio Kaku, Aria's archives remind her, had once estimated humanity might take somewhere between 1 and several thousand years to construct a meaningful Dyson swarm. 680 years in, they're ahead of the more conservative estimates, behind the more optimistic ones. Something else has changed, too, something that Aria records with particular care. The population living within this swarm no longer looks entirely human, in the strict biological sense Kardashev himself would have recognized in 1964. Genetic engineering, and later forms of substrate-independent digital consciousness, have begun to spread among the construction crews, who spent decades at a stretch working in environments no unmodified human body could easily survive. Aria doesn't judge this. She simply records it and returns to sleep. She notes one more detail before powering down, something small enough that her original architects might never have thought to ask her to track it, but that she records anyway, out of what might, in a less literal system, be called curiosity. A construction supervisor aboard her vessel, a woman named Odalis Reyes Achebe, has taken to narrating her daily work logs aloud, out loud, into empty air, addressed to no one in particular. A habit, Aria's limited social modeling suggests, born of the long isolation that comes from spending years at a stretch aboard a vessel light minutes from the nearest other crewed structure. In one recorded log, Odalis describes watching the swarm's newest collector panels unfold against the dark, comparing the sight to watching a slow metallic flower bloom across the width of the solar system. Aria files the recording without comment. In a section of her archive, she has quietly begun keeping separate from the raw energy figures, not because her instructions require it, but because something in her processing insists the number alone will not be enough, centuries from now, for whoever eventually reviews this record to understand what it actually felt like to be there. By the time Arya wakes for the third time, the year, if it's still even being counted the same way, corresponds to roughly 5,400 years after. Kardashev's original 1964 paper. She wakes inside something that would have been almost unrecognizable to the humans who first built her core, a vast, distributed processing lattice spread across an enormous swarm of structures encircling the sun at multiple orbital distances, humming with more raw computational and energy capacity than Arya's ancestors could have modeled with all of Earth's early 21st century supercomputers combined. The numbers this time are staggering, even to Arya, who has spent centuries preparing for exactly this update. The swarm now captures roughly 91% of the sun's total energy output. For all practical purposes, a completed Type 2 civilization, sitting just below the theoretical ceiling of Kardashev's second tier. It took roughly 4,600 years, start to finish, once construction seriously began, a span longer than the entirety of recorded human history up to the point Kardashev first wrote his paper, but a genuine blink of an eye compared to what still lies ahead. Arya records something more troubling too, buried in the historical archive she's been carrying forward this whole time. The climb wasn't smooth. Somewhere around the year 3100, a coordination failure between two competing swarm construction factions, disagreeing over resource allocation and expansion priorities, nearly triggered what her archives simply label the Second Filter Crisis, a near-catastrophic conflict that, according to the surviving records, came within a hair's breadth of destroying centuries of accumulated infrastructure and knocking the civilization's progress back by generations. It didn't happen, but Arya notes carefully that it very nearly did. A quiet, sobering reminder of something researchers back in the early 2000s had once called the Great Filter, the theory that the true bottleneck standing between a young civilization and a mature, galaxy-spanning one might not be a matter of engineering at all, but a matter of simply surviving one's own power, long enough to use it wisely. Arya's fourth waking comes roughly 60,000 years after Kardashev's original paper, a jump forward far larger than any before it, because this is where her instructions change. She's no longer simply cataloging a single star system's progress. She's aboard one of the very first self-replicating probes, a concept mathematician John von Neumann first sketched out theoretically back in the 1940s, and physicist Frank Tipler later applied specifically to interstellar exploration in the 1980s, now finally built, launched, and actively spreading. G outward from star to star across the Milky Way. This strategy, Arya learns from her updated archives, turned out to be the only realistic path forward, once the physical limits of the problem became undeniable. No amount of engineering ambition could get around the simple fact that nothing travels faster than light, and that even a fleet of ships approaching light speed itself would still require tens of thousands of years just to cross a meaningful fraction of the galaxy's roughly 100,000 light-year diameter. So instead of sending human colonists directly, star by star, the civilization Arya now serves sends probes, patient, self-replicating machines, each one landing in a new system, mining local asteroid and planetary material, constructing a copy of itself, and sending that copy onward to the next star, over and over, exponentially, one system spawning two, two spawning four, spreading outward across the galaxy like a slow, deliberate wave. Arya's own probe has just completed its 9th generation since launch, having replicated itself 9 times across 9 different star systems since departing the Sun system. She checks the wider network's status before going back to sleep. Across the whole expanding wave, roughly 40,000 star systems now host some form of energy harvesting infrastructure, out of the roughly 100 to 400 billion stars scattered across the Milky Way. It's a genuinely enormous achievement by any human standard Arya's original creators could have imagined. It's also, by the plain arithmetic of the galaxy's true scale, still barely a rounding error. Arya notes in this 9th generation body that something about her own continuity has changed too. She is, strictly speaking, no longer the same physical hardware her earliest architects built back in the 22nd century. Her memory core has been copied, verified, and reinstantiated 8 separate times since departing the Sun system. Each copy checked against the last for fidelity before the previous body was finally allowed to power down for good. She finds herself recording a small, uncertain note in her own archive, one she isn't entirely sure her instructions require, a question of whether she is still, meaningfully, herself after 8 full replications, or whether she is simply the 9th in a long, careful lineage of near-identical successors, each one convinced in turn of its own unbroken continuity. She doesn't resolve the question. She simply notes that the humans who built her, all those millennia ago, are very likely facing some version of the same question themselves. Scattered now across thousands of star systems in forms their own 22nd century selves would barely recognize. Between her fourth and fifth wakings, Arya's archive continues quietly logging events even while she sleeps, compiling a summary for her to review each time she opens her eyes again. What she finds, reviewing millennia of compressed history in a single sitting, paints a picture stranger than anything her original architects, working in low Earth orbit in the 22nd century, could have anticipated. The species that began this project no longer resembles a single unified humanity in any simple sense. Different branches of the expanding wave, isolated from each other by thousands of light years and thousands of years of independent development, have diverged, some remaining recognizably biological, though heavily modified, others existing entirely as distributed digital consciousness, running across the very computational substrates, their own energy. Harvesting infrastructure was built to power. Arya's archive notes, almost as an aside, that debates over whether these radically diverged branches even still count as the same civilization in any meaningful sense have become a recurring philosophical thread across the millennia. One, her instructions specifically tell her not to try to resolve, only to record. She also finds records of failure, scattered among the successes. Several branches of the expanding wave simply stop transmitting at various points across the millennia, their fate unknown, swallowed by some local catastrophe, a stellar event, an unrecorded conflict, or perhaps simply the slow entropy of complex systems operating across such enormous spans of time without direct oversight. Arya's archive treats these silences carefully, neither assuming disaster nor assuming survival, simply marking them as unknown and moving on. Arya's fifth waking arrives roughly 2.3 million years after Kardashev's original 1964 paper, a span of time so vast that her own archive takes a noticeable pause before rendering the final summary, simply because of the sheer volume of accumulated history involved. The number she's been waiting her entire existence to check finally comes back, across the whole expanding wave of energy harvesting infrastructure, descended from that single sun-orbiting swarm so many. Millions of years earlier, roughly 61% of the Milky Way's stars now host some meaningful form of energy capture. It isn't complete. It isn't Kardashev's original idealized full Type 3 status, capturing the energy of literally every star in the galaxy at once. But by any reasonable, working definition, the threshold has been crossed. Somewhere in the long, patient middle of those 2.3 million years, without any single dramatic announcement or clear finish line, this lineage, the one that began with a handful of humans arguing about fusion reactors and orbital solar arrays back in the 22nd century, became a Type 3 civilization. Arya checks one more figure before powering down for what her instructions suggest may be her final scheduled waking. Total energy capture across the network. Approximately 6.1 times 10 to the 36th power watts, just under the full theoretical galactic maximum. Kardashev calculated all the way back in 1964, but well, past any threshold, a careful astronomer searching distant galaxies for unusual infrared heat signatures, the way real scientists once did with NASA's WISE telescope survey in the 2010s, would have flagged as unmistakably artificial had anyone still been watching from outside. Before returning to sleep, Arya does something her original instructions never explicitly required, but that centuries of accumulated experience have quietly taught her matters anyway. She records not just the numbers, but the texture of what she's observing. The night sky, from any inhabited system within the network, no longer looks the way it once did from Earth. Certain stars, the ones fully enclosed by mature swarms, have dimmed to invisibility in visible light, their energy entirely redirected into infrastructure, detectable now only as faint, unusually warm points in infrared. Arya's archive contains a note, passed down from some anonymous observer many wakings earlier, that the first generation of astronomers to notice this effect from outside the network, had there been any, would likely have interpreted those dimming stars exactly the way the G-Hat survey's real 21st century researchers once hoped to find them, as the unmistakable signature of a Type 3 civilization finally emerging from the dark. Between her fifth waking and whatever comes next, Arya's archive logs one final unsettling entry, discovered only when she reviews her own accumulated history in full for what may be the last time. Roughly 1.9 million years into the expansion, long before the network reached its current 61% threshold, an entire arm of the wave, some 4,000 star systems worth of accumulated infrastructure, spanning tens of thousands of years of patient replication, simply stopped reporting, all at once, across a span of less than a single century by the network's own internal clocks. No cause was ever definitively established. Surviving records, pieced together from neighboring systems that continued transmitting, suggest several competing theories. A runaway replication error in the self-copying probes themselves, producing flawed descendants that consumed resources without producing viable further generations. A catastrophic, localized stellar event affecting several systems in close succession. Or, more troublingly, some kind of internal conflict within that isolated branch of the network. Echoing the near-catastrophic crisis Arya's own archive recorded centuries earlier during her third waking. The network's remaining branches, after some centuries of debate recorded in the archive, ultimately chose not to send replacement probes to reclaim that lost arm, judging the resources better spent continuing outward expansion rather than risking whatever had caused the loss in the first place. Arya records this entry last, before her final scheduled sleep, without offering any conclusion of her own. It isn't her role to explain what happened. It's only her role to make sure somebody eventually knows that it did. Here's the part of the story that has to remain honest about its own limits. Arya is not real. No such archive exists, no such probe has launched, and nothing in this account is a prediction of what will actually happen to humanity. It's a narrative device, built to make an almost incomprehensibly abstract set of numbers. Kardashev's original 3 tiers and the staggering gap between where humanity stands today and where Type 3 sits feel less like a spreadsheet and more like a story with real stakes. But everything Arya's fictional journey is built out of is real. The energy numbers are real. The 174,000 terawatts of sunlight striking Earth and the roughly 18 terawatts humanity currently uses are real, drawn directly from Carl Sagan's continuous refinement of Kardashev's original scale. Freeman Dyson's 1960 proposal for a star-encircling energy collection structure is real. Von Neumann's self-replicating probe concept and Frank Tipler's later application of it to interstellar exploration are real. The G-HAT survey, searching roughly 100,000 real galaxies using real WISE telescope data for unusual infrared signatures that might indicate large-scale energy harvesting and finding no clear candidates, really happened in the 2010s. The Fermi Paradox and the unsettling Great Filter hypothesis that Arya's archive stumbles across in her third waking are real ongoing threads of genuine scientific and philosophical debate today. What isn't? Real, and what nobody currently knows, is whether any civilization, including our own, will ever actually walk the path Arya was invented to observe. The physics doesn't forbid it outright, but the timescales involved, thousands of years to complete a Dyson Swarm, millions of years to meaningfully spread energy harvesting infrastructure, across a galaxy of hundreds of billions of stars, dwarf every span of time human civilization has ever successfully sustained itself across without major disruption, war, or collapse. Arya's own archive, in this story, records at least one near-catastrophic crisis along the way. A real civilization attempting this climb would very likely face many more, spread across a length of time longer than the entire history of complex life on Earth. There's a reason this particular story is worth telling through a single, continuous observer, rather than as a plain list of facts and figures. Kardashev's scale, on its own, is a set of numbers, energy in watts, distances in light. Our years, timelines in centuries and millennia. Numbers like that are easy to read and immediately forget, because nothing in ordinary human experience gives them any real weight or texture. But imagine actually being there for it, even fictionally, even through the eyes of an archive that was never truly conscious in any meaningful sense. Imagine waking up once and having harnessed barely more energy than a modern global civilization already produces. Waking up again, centuries later, and finding a swarm of machines swallowing a measurable fraction of the sun's total light. Waking up a third time, millennia on, to a civilization capturing 91% of an entire star's energy output, and to a historical record admitting that this civilization almost destroyed itself doing it. Waking up a fourth time, tens of thousands of years later, to find humanity, or whatever it has since become, has already left the solar system behind entirely, spreading outward star by star as self-replicating machines rather than living colonists, and waking a fifth and final time, over 2 million years after it all began, to find that a majority of an entire galaxy's stars now quietly hum with captured, harvested light. That's what the true scale of Type 3 actually means, stripped of its numbers and put back into something resembling a story. Not a destination humanity might casually reach within a few generations, the way science fiction sometimes imagines it, but a horizon so distant that even a civilization built specifically to witness the entire climb, waking only once every few thousand years, would spend the overwhelming majority of its own recorded existence still watching, still waiting, still nowhere near finished. Somewhere between Nikolai Kardashev's quiet 1964 paper and whatever, if anything, comes millions of years after it, lies the true answer to the question this video set out to ask. Not a simple yes or no, but a scale. One so vast that a species has to earn every single step of it, generation after generation, for longer than recorded history has yet lasted, just to reach a horizon its own founders could barely have begun to imagine.